Welcome back to Data Science for Humans. Today is Part 9, SQL with Python. Let's quickly review what SQL is. So recall from last time that we were talking about SQL being a language that we use to communicate with a relational database server. SQL is the language. Now we informally refer to the actual SQL product, like Microsoft SQL Server or MySQL, as SQL. But we're going to be focusing on writing specific SQL queries to pull data out of databases. And today our focus is on Python. And today we're going to set a special challenge for ourselves. So the World Bank, with the same data that we used in the previous segment, the World Bank regularly publishes some global development data, and we've compiled it for Canada, the United States, and a few other countries. This data has been stored in a SQL database, and today we're going to find out if access to broadband internet has had any meaningful impact on a country's GDP. Now, in other classes, sometimes I show how we can do this for labor participation rate or sometimes youth crime rates in the province of Ontario. But for today, we're just going to look at net access versus GDP. And we'll be using Python to conduct this regression analysis. I've jumped over to Spider. The first thing you'll want to do on your machine, if you're accessing MySQL, is you'll want to run this command in your console called pip install mysql-connector-python. This will install the MySQL connector, which will allow you to connect to MySQL databases using Python. I've already installed this connector on my machine, so I'm ready to go. If you have trouble with this on your local machine, this is a time where you'll want to talk to whoever your company's IT department is. They may have restrictions on installing software like this. But once you've got it installed, you can follow along with this tutorial. So, I need to import the SQL connector and the SQL Alchemy engine in order to be able to connect to my SQL server. So we'll create a connection, and then we'll actually read in our SQL. So check this out. We're going to import pandas, import our stats models, import this SQL connector, and import SQL Alchemy as well so that we can query from our database. So I'm using Control-Enter and selecting this text to run. Again, if you're on a Mac, select this text and hit Command-Enter. So I've imported my libraries. I'm ready to go. Next, I'm going to create my engine. I'm going to create my SQL reading engine. And I use this by specifying the special URL that says we're using the MySQL connector. Here's my username, root. Here's my password, PS699 secure. Here's the computer I'm connecting to, my local host, and the port. And the slash and the characters after the slash say I'm using the World Bank database. So let's go ahead and run that line. And now we have a connection that's open. Okay. First thing we're going to do is try to read in from SQL our country metrics where the indicator is our GDP or the indicator is this internet and broadband access. And notice I have this extra parameter called con. This is saying which SQL connection I want to use. Now pd.readSQL, this is pandas that is actually handling the SQL reading from SQL for us. We're just using a select query. So let's run this, and you'll see now I've got a data frame. I've got 402 records and 4 columns. I've got my country column, I have my indicator, I have the year, and I have the value. And we know we're dealing with all numbers because notice this column is nicely colored for us. Now, so that we can do some analysis later on, I'm going to set my index to be my country, then my indicator, then my year. So I'll run this line, and you'll notice that now this data frame changes a little bit. We now have our index column, which is our country, then our indicator, and then the specific year, and we have our value column. Okay, now we're ready to go. Could we run a regression on this data right away? Is this regression analysis ready? Not really. What we can see here is we have a bunch of rows with one column value. Not really useful for running a regression analysis, but it turns out that Pandas has a really awesome method for us called Unstack. And the reason that we set up the index the way that we did is this allows us to pivot our rows into columns. So check this out. I'm going to say df2 is equal to df2.unstack level equals 1. And I'll select this row and hit Control-Enter. Now check out what we've got. Check out what our data frame looks like now. So we have one column where we have our broadband internet access value, and we have one column with our GDP. And notice we have some rows where we have not a number because we didn't have broadband access going back that far for our internet broadband access, but we do have records for our GDP. So we should still be able to do a fairly meaningful regression analysis here. Now, right now, this data frame is a bit hard to work with because these column names are pretty unruly. So let's rename those columns, shall we? So df2 equals, or df2.columns, excuse me. I'm switching between R and Python today. I'm going to rename these columns to net access and GDP. So now I've renamed these columns. Or excuse me, I need to select this row. I'm used to RStudio. Here we go. These columns are now renamed. I have net access and GDP, and we've indexed by the country name and by year. Cool, right? Excellent. Since we do not care about rows where we have NA, so we don't really care about rows where our broadband internet access was NA, in other words, historical years, we're going to do df2 equals df2.drop NA. This is going to drop all the NA rows for us. We're down to 96 rows. Now let's set up our regression analysis. Our Y variable is going to be df2, our GDP, so that's going to be our response variable, and X is going to be our df2 net access. And we'll also add a constant to that, so we're not forcing our regression to go through 0. And we'll create our model. So model equals sm.ols yx, and we'll fit, and we'll create our predictions, and set that equal to model.predict x, and finally we'll print out our model summary. Ready to see how this works? For those of you paying attention at home, you'll notice that on line 24, I forgot an equal sign. If you spotted it and I didn't, congratulations, you win 2 internets. All right, let's try running that again. Check it out. We've run our regression, and now we get our regression results. So we see that we have an adjusted R squared of, or we have an R squared of 236 and an adjusted R squared of 228. Now, from one of our previous lectures, recall that our adjusted R square will remain, will either increase or decrease. R squared will remain the same or increase when we add more variables, but they may not improve our model. And our adjusted R square will compare the variability that we're seeing to chance. So in other words, do the variables we're using explain our model better than chance? If that's the case, the adjusted R squared will improve. In this case, if we look at our scores, we see that we have, again, the R squared of 236 and an adjusted R squared of 228. Already, we're only explaining about 23% of the variability in our data using our model. So chances are there's some variable that's affecting GDP more than just internet access. And our adjusted R squared is worse, which suggests that we're not doing much better of a job than, say, random chance. So while it does suggest that there is an impact, because we can also see that the coefficient is positive. So chances are there is some impact of net access on GDP. What our model is showing is that there's probably something else that's accounting for that increase in GDP. However, that being said, we can still claim a minor victory. Not only have we read in data using SQL, but we've used it in a regression analysis in Python. How cool is that? Thanks for joining me, and I'll talk to you again sometime soon.